Hey, bebe, vedela Dian. Test. Test. One. Okay. Test. Okay, almost 2 minutes past 8, I think. We'll start in few more minutes. We'll wait until the students join and then can continue. Right? I think the audio is. YouTube chat is also. Zoom chat is so. How about the YouTube working? Okay, I'll briefly start today's proceedings, but we'll wait few more minutes until all the students join, because I don't want anyone missing of the parts. I think you have any issues related to audio not working properly, or audio is not not that nice if the noise is a little bit too loud, or පොඩ්ඩක් හරි නෑ වගේ නම් audio එක, you can send a text to the Zoom, right? In case you have any issues using the Zoom chat, that means your Zoom hasn't been updated. Now I'll give some general instructions before we start until students join, which can be repetitive if you join the first seminar or if you watch that recording. Things I am telling in the beginning can be repetitive, but since there can be students who are joining newly only for this session, there can be issues. So I'll make sure that you are aware of all the සද්ද ටික වැඩි කරන්න. සද්ද අඩුද එහෙනම්? සද්ද වෙන් වැඩි කරගන්න බැරිද? The audio too low. එහෙනම් මදිද තමයි? අඩුද එහෙනම්? What about the others? I think the volume huh? Yeah. Nah, ඒ වගේ issues කියන්න, it's fine. Maybe it's from on your end, maybe it's on our end, but continuously let us know the issues. Sorry. So I'll take 3-4 minutes and while checking all the technical issues are sorted, now it's 6 minutes past 8. Anyways, I'll give you the general instruction on what we are doing today and what you should know before we start. Things will be repetitive if you join the first session, just listen to those, it's fine. And anyways, we'll be finishing at around 11. We'll be finishing at around 11. And before starting, yeah, technical issues හරිද කියලා බලන ගමන් I'll let you know whether everything is going smoothly. Of now everything seems fine, eh? Okay, I think everything is fine. We'll start. What are the issues? If you have issues, you can Zoom chat. Okay, I think Right, few instructions before we start. What are we doing today and what is the plan? First of all, you need to have the tute with you. If you don't have the tute, it's on the WhatsApp channel. If you are not on the WhatsApp channel, on the YouTube live, you have the WhatsApp channel on the description. You can click on it and join the WhatsApp channel, and you can see the previous messages. And you can there's a drive link saying that this is the tute posted today morning. You can get it. So if possible, get a hard copy. It would be better. If not, even a soft copy would do. And if you are on the Zoom meeting, if you want the tute, right? If anyone wants the tute, who does not have the tute, you can text this number and get a soft copy. මේ number එකට මේ tute එක යවලා තියන්න. This number tute එක යවලා තියන්න. හරි. So if you want, you can get the tute from that as well. And because today's tute is very important, because we'll be mainly working with the tute. Now last day when we were doing chemical calculations, we first revised all the theory and then we went to do questions. But here, if we if we use that approach, we would have some time issues with managing the time, because electrochemistry is a much more longer lesson with more components. So the easiest and the most efficient and the most smartest way to cover this for a student who is having A levels, who is having O levels in a month, you don't even have a month, I think, close to a month again, is to revise it doing some past paper questions. So today plan would be not just doing past paper questions, then it won't help you, because most of you have issues regarding these units, then no point just doing a past paper question. But I would be doing questions while revising all the theory. So before the session, before ending the session, we'll make sure that all the theory has been revised, right? Okay, and then before starting, the general instructions related to this seminar. One, if you haven't watched the first seminar, this is the second seminar. The first seminar we covered chemical calculations. So everything related to that has been sent to the group, has been posted on the group. So you can watch those later. Two, still the recording of the first seminar is available. But the recording of this seminar won't be available for that long. The recording of the first seminar was available only for the reason that students said us that they got to know about these seminars later, and then therefore can we keep it. That's the only reason, because we need to make sure that you join the live sessions and cover it as soon as possible, because the recordings option, you all know that it's not the best option to go, otherwise then it will be again another recording which you haven't watched. I don't want that to happen. That's the only reason we are removing, otherwise nothing will happen, just keeping it, having it, but we'll be removing this recording as soon as possible. And then 3, if you are having any issues related to the seminar, let's say any technical issues, send a text to the Zoom, or else send a text to the YouTube live. But it's very difficult to go through the Zoom chat. If you were there on the last seminar, you would know it's very difficult, because I am getting hundreds of messages, can't read all of those. The Zoom chat it's difficult, but the YouTube live can be read. So I'll check the YouTube live every maybe 15 minutes, 30 minutes when I have time. But if I miss anything, if a technical issue is missed, again send a message to this number saying that the audio is not good or the video is lagging or whatever, because that would affect a lot of you. If you have anything related to chemistry, if you have any theory issues, you can send it to the chat once or twice. If I see it, if you get lucky, I'll answer the question. If not, again send it to this number, and in like few days I'll answer it. Now we had the last seminar on Friday, still I couldn't finish all the replying all the text you sent. I can see over there were hundreds of messages, so I couldn't reply to all, but I am still doing it. Somehow I am replying. There were a few remaining. I think it can take some time, but I'll definitely make sure I attend to it personally. That's the thing. And since this is an English medium class and English medium seminar, I'll be using mostly English. 95% of the things I am explaining will be done in English. But if you have any issues related to the subject which you find it easy to understand in Sinhala, or if you want to ask the question in Sinhala, em ප්‍රශ්නයක් නැහැ. Sinhala පුළුවන්. Ask in Sinhala, it's fine. හරි. Then I think we can start. Yeah, everything is sorted, everything is fine, understood. ඔක්කොම හරි. We'll start. අද වැඩ පටන් ගමු. හරිනේ? Can you hear me නේ? හරි. Okay. Good. දා කරපු වැඩේ. Sorry, test. Is it fine now? Check today. It's better to figure out everything before we start. It might take some time, but it's easier for then all of us. Yeah, you can. Yeah. Yeah. And please don't ask questions related to our A-level classes. Everything will be informed later. Hari, now, of course, you might be starting to think about A-level classes, but all of you might not do A-level science or maths, right? If you are doing A-level science or maths, now in the first seminar, I gave an introduction about myself and what we are doing. දැන් හරිද? You didn't hear anything. Huh? Everything put up බලන්න. For the last 5 minutes we didn't hear anything. Okay. Yeah, if anyone has issues may අර number එක තියෙන්නේ just text that number. හරි. If someone texted, thank you very much. I don't know how we missed it. Sorry about that. Okay, now you can hear now. හරි okay. එනවද? Okay, hari. Aku nak balan nanti. Okay, hari, right. Today the things are not going that smoothly neither. කමන්නේ මට කරගමු ලයිව් එකට යනවද okay now good නේ නෑ දැන් හරි now everything we tried to contact you sorry about that හරිද voice nahi කියලා හින්දි වල නුත් දාලා so please see hari ඔයගොල්ලෝ chat එකේ දැම්ම කියලා if I am not seeing හරිද wait now I'll just check me sorry අවන්නේ මේක රගල කරමු is the tute being sent to the group oh tute is on the group so the YouTube audio is not working at the YouTube session anyone can't hear you hari දැන් හරිනේ okay මෙන්න මේ ආයේ tute එක දාන්න group එකට link එක දාන්න some students can't find now you can hear නේ in case you can't hear මෙන්න මේ number එකට I sent you a number නේ මොකක් වුණත් මේ number එකට WhatsApp hari call hari මොන hari කරලා somehow let that person know හරිද because I can't be focusing on that hari පැහැදිලි meantime if there's any issue our technical team will attend to it hari එක බලාගෙන යන්න හිමීට hari now we need to continue now we are a little bit late with this මේ ඔක්කොමත් එක්ක පොඩ්ඩක් එහෙම වුණා ළමයි okay hari now since you didn't hear I'll quickly recap on what we learned regarding electrochemistry hari you have three things to learn one electrochemical cells electrolytical cells and corrosion of iron right hari now what I am going to do here is I'll summarize all the ideas while doing questions now from the last session the difference is the last session we did all the theory at first and then tried the questions but here it's not that efficient because we have a relatively higher amount of content hari we have a relatively higher amount of content in that case what we are going to do is while doing questions learn all the theory backgrounds not just doing questions then no point I'll be summarizing all the first half of the session or more than half around 60% of the session time wise, we will be discussing about electrochemical cells and electrolytical cells. In the last part of session, I will be focusing on corrosion of iron. Right, that was the first idea I gave you. Then we are starting to understand the sixth question on the tute. That's why the tute is very important. We are starting to understand the sixth question. But before starting the sixth question, right? But before starting the sixth question, Lamai, we will be understanding briefly what an electrochemical cell or what an electrolytical cell is. Electrochemical cell or electrolytical cell is. We'll focus on the electrolytic cell in a minute, but before that, electrochemical cell. This is the basic structure for you for the electrochemical cell. If you want, since you missed the explanation, I'll start from the beginning. A very simple structure, even you can prepare this at home. You need a solution which we call the electrolyte. Now there are certain things we need to achieve. Not all the solutions are good electrolytes. But in your syllabus, diluted sulfuric is an electrolyte, right? Normally at your level, just keep in mind that if a solution can give a lot of ions to water, normally things like strong acids, strong bases can act as good electrolytes. Not all the strong acids, there can be some issues related to that, but that's advanced at your level. For you, normally remember that your electrolyte is diluted sulfuric. In A levels, we will be learning more. And one more thing I made very clear before starting these questions, which if you didn't hear, that in this session we will be learning some tips which we learn in A levels regarding electrochemistry, which will make it very easy for you to memorize. Instead of just studying, I will teach you some logics which will make it very easy to memorize these equations which we learn in electrochemical cells and electrolytic cells. Right. Then here, next we have two rods. Two iron rods. We have two iron rods. Two metal rods, sorry. Two metal rods. I'll name it as metal 1 and then metal 2. Nikang chuti pieces of metal, right? And then ideally we will be connecting these two with a conducting wire. This is the typical setup of a electrochemical cell. Now we will learn how these work and how or what is an anode, how does the electrons flow, how does the current flow, and then how to derive where the reduction happens, where the oxidations happen, and hence write the equations and then write the final equation. Very easy. Now believe me, most of you are just studying for this cell, this is the cathode, this is the anode, right? Or else you might be studying which direction the electrons flow, which direction the current flow, then what is the anode, what is the cathode. Most of you are just studying those, sorry. From here onwards you won't be studying, you will logically understand what exactly happens. Right? So in that case, since I am explaining the logic, some of the things I am teaching might not be in your syllabus, but it won't be difficult. It will be very easy to understand. Because as a A-level tutor, it's my responsibility to give you something extra to make it easy. If things are getting more difficult, but with this, things will be very easy for you. So after writing electrochemistry, if you want, you can prepare a small note. Now while answering the questions, we will be preparing a small note as well. Then because this is a revised session, so a lot of things will be happening. We will be answering the tute while preparing a small short note as well. So you can write electrochemical cells as your first subtopic, and then you can just draw this. No need to mention metal 1, metal 2. So if you want, you can draw this small diagram. Make sure you draw it a little bit clearly, neatly. Then we can't do our workings and understand things. Tika lokuwata andin. Hari. Nama tiyena prashna. Hemada. Is it so? Huh? Hari. Okay. Online lamai me YouTube or Zoom. Make sure you don't spam the chat. Hari. Don't make the chats. Don't spam the chat. Hari. That's not nice from you. If you are not interested in learning this, you can leave. If you want to learn, you can learn. Please. Yeah, just draw a small sketch. Nikam podiya නෙමෙයි ටිකක් ලොකුවට පොඩි draw a sketch. Hari? Right. Okay. Odane. Quickly, I'll give you 1 minute. If anyone joined late to the session, if you are on the Zoom, you can switch to the YouTube live and start from the beginning. Hari, balagane ennat puluwan, no issue. That's why we are actually having a YouTube live also. That's one purpose of it. Okay, Hari, right. Then after drawing this, what happens in a electrochemical cell? It's very easy for you. It's very easy. First of all, in electrochemical cells, there are two processes which are very important to. One is oxidation, the other one is reduction. Remember, for electrochemical cells, these processes cannot be forced. It's natural. Electrochemical cell is a spontaneous process, or we call it a natural process. ඒක auto වෙන්නේ. අපිට බලෙන් we can't force it. හරි. So if there are two metals or if there are many substances, the substance which likes to oxidize the most should oxidize. ඔයාට එපා එහෙම කියන්න බෑ. In electrolytic cells, actually we can do that. We'll learn it later. That's the first difference between electrochemical cells and electrolytic cells. So the first thing is, if someone is better at oxidizing, then that will oxidize. Now, if someone doesn't know what oxidizing is, simply releasing electrons. That's the simplest way to explain. Then, if someone prefers reduction the most, which is accepting electrons, it should reduce. There's no option. You can't alter it. Nah, you might be the one who can reduce the best, but we need to do this. Nah, you can't do that. It cannot be forced, right? Okay, then, so briefly, if someone didn't know what oxidation is, releasing electrons. Reduction is accepting electrons. Hari. Now, considering all your examples in your syllabus, now of course even at A levels we might not know all the reactions for all the electrochemical cells in the world, because for that you need to know a list in your head saying which likes to reduce the most or which likes to oxidize the most. Now, if they ask you giving a cell and say, okay, in this cell who likes to reduce the most or who likes to oxidize the most, you should know that, right? You can't just look at it and say, because we can't conduct experiments while we are writing the paper. So even in A levels, there's a certain number of cells we can answer. For O levels also it's the case. For O levels, these are the only things you need to know. There are few elements we are working with: zinc, iron, copper and hydrogen. Zinc, iron, copper and hydrogen, right? And some of you might have heard of a thing called activation series, or we call it the reactivity series as well. There's like a lot of terms we use. We call it the electrochemical series in A level as well. Anyway, if I arrange all of these in that series, I'll explain you why we use that series and what is the purpose of that series. I'll explain you that in a minute. This is the order. No need to write me a note. We'll prepare a note. We'll prepare a very good note later. This is the order: zinc, iron, hydrogen, copper. What happens in this series is, going down the group, going down this series, the ability to reduce increases. Ability to reduce increases. That means, on the other hand, what happens? Going upwards, the ability to oxidize increases. That's the first thing we need to know. Now, no need to study all the elements or all the materials in the world. For you, for electrochemical series, only these can be questioned. Check all the past papers, only those will be questioned. Only those will be questioned. Right. That's one thing. That's one thing you need to understand. Harida? Okay. Then, so going down the group, the ability to reducing increases, going upwards, the ability to oxidize increases. Now we will see if they give you some random, now still don't write anything, we will first try to understand a whole example, a complete example, and then try to prepare a note. Now, normally in an electrochemical cell, they will give you two electrodes, two metal rods. Let's say for an example, as given in the question also, one metal was zinc. The other metal was copper. Just assume, නිකන් හිතන්නකෝ. එකක් zinc, අනිත් එක was copper. හරිද? One is zinc, the other one is copper. හරි. Then they ask you several questions regarding this. නේ? Once they give you a cell, they would ask you several questions regarding this. Hurry. Now for an example, if you just check what kind of questions they are asking. Now if you refer to the 6th question, which we were talking about. So regarding cell U, they are asking to indicate the half reactions in anode. Then of course they can ask the half reactions in cathode. Then they can ask for a total reaction. They can ask things like that. Even if we refer to your textbook, what else can they ask? What have they asked? Normally that's the main goal, to identify the anode and cathode and to write the equations. Isn't it? Very easy. Yeah, to identify the anode and cathode. Yeah, that's it. Hari. Now we will see how that happens. Now if this is too crowded, you have diluted sulfuric. You have the two metals. I'll name one as zinc, one as copper. We have a limited amount of combinations because we only have 4 things to compare. Zinc, copper, iron and hydrogen. And here you have sulfuric, H2SO4, diluted sulfuric. This is your cell. Now they might put a conducting or a conductive wire here, and then they would ask to identify the anode or the cathode. It's very easy, very easy. No matter what the cell is, this is very important. Most of the students get confused here. All of you think of the plus charges, minus charges. Don't. Now from here onwards, now most of you, I know, remember things separately for electrochemical cells and separately for electrolytic cells. That's because you don't know the logics. But if you think about it logically, once you learn it today, it's very easy then. What is anode? What is anode? The place where oxidation happens. The place where oxidation happens. Oxidation happens here. What is cathode? Place where reduction happens. Place where reduction happens. Right? Oxidation is the place where, anode is the place where oxidation happens. Cathode is the place where reduction happens. Is it clear? Right. Then what happens here is, once they give a cell like this, the first thing you need to do, what's the order? Zinc, iron, hydrogen, copper. The first thing it's zinc, iron, hydrogen, copper. Right. And then locate see where these two are in this series. Zinc is here, copper is here. Now what we know is, I'm proposing a method, right? What we know is, going down the group, the ability to reduce increases. Going up the group, the ability to oxidize increases. Then we know zinc likes to oxidize the most. Zinc likes to oxidize. Zinc likes to oxidize the most. Right? Then what about reducing? Then don't think that if zinc is oxidizing, copper might be reducing. No, copper can't reduce. Why not? Can someone answer on the YouTube chat? Why can't copper reduce? Now, if I am being logically fair, now I am saying going down the group, the ability to reduce increases. Hari, that's correct. Then this likes to oxidize, because යටට යන්න යන්න reduce වෙන්න තමයි කැමති. නේ? උඩට යන්න යන්න it likes to oxidize the most. හරිද? හරි. Then this prefers to oxidize. Then I am saying that oxidizes. Then you are asking, will this reduce? Then I am saying no. එහෙම වෙන්න බෑනේ. There should be explanation for that නේ. Does anyone know? ඇයි එහෙම වෙන්නේ නැත්තේ? What is the issue? Why doesn't that happen? What is the issue? Why doesn't that happen? Any answers? කියන්න බලන්න. This is the 6th question ළමයි. කියන්න ළමයි. Even on the Zoom, try to answer. I think I can read. Still, the messages are manageable. Good. Right? There is sulfuric acid. That's a separate story. Sulfuric acid is there and you might have learned that it is the one which is reducing, but that won't answer the question. That's not logical. Now I am saying zinc is oxidizing because it can. Hurry. Then copper should be reducing. I think it prefers to reduce. Then I am saying no, it's not reducing. Why? What's the reason? Yeah, now you are saying because hydrogen will be formed due to sulfuric. That's because you know, you might have learned it and you might know. Hurry. But that won't answer why copper can't reduce. That won't answer the question. Hurry. Because copper can't reduce, sulfuric will take action and reduce. Hurry. That's true. Hurry. But why can't copper reduce? Because now you can see here also. Now, if we consider hydrogen and copper, what is below? Copper is below. Then even then hydrogen, copper should like to reduce. Anything sulfuric copper should be better. No? Why doesn't that happen? Why doesn't that happen? Because we know going down, it prefers to reduce. You think hydrogen copper is even below hydrogen, then it should reduce. Why doesn't that happen? Now few of you have understood. Now one student is saying copper is inert. No, copper isn't inert. That's wrong. No. No, most of you haven't still understood the question. Now, without teaching this, I can go and just tell you to just study, it's fine. Try to understand the idea. Now, I'll repeat again. Going down the group, the further down, it prefers to reduce the most. Then, copper should prefer to reduce than hydrogen. Copper should prefer to reduce than hydrogen. But actually, hydrogen is reducing. You can see, some of you might know if you have learned it, this is the one which actually reduces. What is the reason? Yeah, some of you have understood copper is a metal. Metals can't reduce. Why is that? Why can't metals reduce? Because metals will always release electrons. Those can't accept electrons. In case they ask that in a question, they can very easily ask. Even though copper is below hydrogen, in this cell hydrogen is the one which is reducing. Why is that? Because we know going down it's better to reduce. Your answer should be copper is a metal which can't reduce. Metals won't reduce. That's the answer. Anyway, because of that, only for these two, for the metal rods using this, we are only figuring out what oxidizes. Api මේ list එකෙන් හොයාගන්නේ what oxidizes only. We are not thinking about a reduction because metals can't reduce. Then always what is inside this will be reducing. මේක ඇතුලේ එක තමයි always reduce වෙන්නේ. Hari? So that's the framework, right? So in question, in part 1, in my method to answer the question, in part 1, figure out what oxidizes. What oxidizes? Hari? What oxidizes? Sorry. What oxidizes is part 1. Hari. Done. Then part 2 will be automatically what reduces. It will be always for you. What will it be always? Sulfuric for you. Always it will be sulfuric. If not, now in case they want to make the question a little bit difficult, instead of sulfuric they will give something else here. Instead of sulfuric, maybe another acid, then that will be the one which is reducing. Hari? Not the entire sulfuric. Here we have H+. In this sulfuric we have H plus. That H plus will be reducing. So I'll repeat again. Once they give you an electrochemical cell, first write down these four and see out of the given two metals which is on the top. Udama inne kawuda balanna. That one will be oxidizing. Then don't think about reducing using this list. Always the one which is reducing is this. Onna lassana framework ya kadagena enna. Now we are trying to understand how to answer a question easily, right? Now what we have to do is write the equations. Write the equations. Write the equations. So the third one, write equations. In university that's how we write equations. But write it properly. Equations. So how to write the equations? Kohomada lama equations ganne? You have zinc. Now we know zinc is oxidizing. For this question zinc is oxidizing because zinc is higher than copper. Now I assume all of you are following. Any issues let me know. All of you are following. එතකොට මොකද වෙන්නේ? Zinc oxidizes to zinc 2 zinc oxidizes, that's enough. Zinc oxidizes. And then the other one we know H plus in sulfuric will reduce. This will reduce. Is that clear up to now? Always just as a fact remember, that's the first thing we are remembering without understanding. Since metals can't reduce, always the H plus in this acid in the liquid or the solution will be reducing. For an electrochemical cell. Right. Then H plus will be reducing to H2. H plus will be reducing to H2. Now you can balance this. How to balance? You have two hydrogens on this side, so you need to have two on this side as well. We put a 2 here and then we simply balance the charges. We do a thing called balancing the charges. On this side the charge is 0. On this side the charge is plus 1 into 2 plus 2. Now if I said this last session as well, if I am going a little bit too fast, if you are thinking so, maybe the reason is you not knowing any of these. I might be a little bit too fast. Then you better start from the beginning and watch the YouTube live slowly. If you have no ideas about these concepts. So plus 1 into 2 is plus 2. But this side the charge is 0. Nothing charge is 0. Then we add 2 electrons. Why do we add 2 electrons? Because the charge of 1 electron is minus 1. Then this is how it is balanced. The charge here is plus 1 into 2 plus 2. Charge here is minus 1 to 2 minus 2. So the total is 0. 0 is 0. That's why it's 0. The link, the tute link is on the description. I think I sent it to the group again. Yeah, it's again on the group. Right now 2H plus another. Now is it clear? H plus goes to hydrogen. Since you have 2, now what are we doing is balancing. Balancing should be always equal. The atoms, charges, everything should be equal on both sides of our equation, left side and right hand side. So here H plus goes to H2. It goes to hydrogen. Hydrogen exists as H2. Since you have 2 hydrogens here, to balance it you need to put a 2 here. Then consider the charges. The charge is 0. Charge again, you should have something visible here. Here we don't have anything. So the charge on this side is 0. But the charge on this side is plus 1 into 2 plus 2. The charge is plus 2. The charge is 0. So to make that plus 2 a 0, you need to add 2 electrons, which is minus 2. Which again makes sense. Why? We know that this is reducing. What was reducing? What was reducing? Accepting electrons. It has accepted electrons. So this one has accepted electrons going to H2. Which is correct. Right. Then the above one, oxidation part. Here you should have an idea on to which cation zinc goes. Normally it goes to zinc 2 plus. Normally zinc goes to zinc 2 plus. So all of these will do that. According to your syllabus, Lamai, all of these will go to 2 plus if possible. Whenever it gets the opportunity, zinc will go to zinc 2 plus, Fe will go to Fe2 plus, copper will go to copper 2 plus. So nothing to remember, all are the same. Zinc will go to zinc 2 plus. Now try to balance this. How to make a balance? How to balance this, Lamai? one zinc atom, so it's already balanced. But the charges, this side the charge is 0 because we can't see anything. Here it's plus 2. So to remove that plus 2, you need to add 2 electrons. Clear the? Right. Then what happens? And they expect you to write the physical states as well. Normally for these units it's better if we can write the physical states. So you know the physical state, right? Hydrogen is a gas. H plus always, always these ions. Now you haven't written anything, we haven't still prepared a note. In that note, I'll make sure all of these small tips and tricks will be written. When you have an iron එකක් තියෙනවා නම් like Fe2 plus iron කියන්නේ මේ IRON නෙමෙයි, zinc 2 plus, copper 2 plus, H plus, all of these ions are aqueous. Those are aqueous. Hari? So this is aqueous. Zinc, what we know, zinc කියන්නේ මොකද්ද? මේකනේ බං zinc කියන්නේ, this is zinc, it's a solid, right? Obviously it's a solid, right? So these are the two equations. If you want, you can add these two in a way that the electrons are simplified. We'll discuss in a minute. Hari, before that we'll complete everything we have done up to now. You can add these two, cancelling these two electrons. Hari, we'll discuss in a minute. Right, so that's the idea of an electrochemical cell. Hari, one more thing, we need to know what a anode and what a cathode is. For that also we are not studying anything. මතක තියාගන්න wherever oxidation happens, this is not dependent on whether it's an electrochemical cell or an electrolytic cell. Wherever oxidation happens, it is the anode. Harida, wherever oxidation happens, it is the anode. So maybe in anode oxidation, cathode reduction, right? That means oxidation happens here, so zinc is the anode. Oxidation happens here, zinc is the anode, right? Then we can't say this is the cathode. Why? We can't say that is the cathode. Cathode should be a physical thing. Cathode should be a physical thing. So if zinc is the anode, we call the other one the cathode. Then you might ask, isn't it a little bit confusing? Why? Because if someone really thinks this through, it says cathode is where reduction happens, anode is where oxidation happens, right? You can understand the difference. Now I am saying anode is here, and of course we can see zinc is oxidizing, which makes sense. But it doesn't make sense here. Why? Because I am saying now cathode is the other one. I am saying this is the anode because oxidation happens. And I am saying the remaining one is the cathode. Why? Because I am saying that cathode is where the reduction happens. But we can see reduction is something else. What actually happens is cathode is not what reduces, anode is not what oxidizes, it's actually where it happens. The H plus in this will reduce near this. May hariya thamai reduce wenne. Close to that. That's why we call it the cathode. That's the difference. It's not actually what reduces is the cathode, it's where reduces is the cathode. Where it reduces. These H pluses will come near to the cathode and then reduce. Now quickly I'll summarize what we did. Quickly summarize karamu. First thing, they will give you an electrochemical cell. You need to identify an electrochemical cell. The structure is like this. No battery, nothing. Just two rods, a solution and a wire. That's it. If it is a battery, it's not an electrochemical cell. Clear? Right. That's number one. Identify it. Number two, from here onwards, you need to identify what oxidizes. For that, very easy. The competition is between these two rods. This is the order. Higher the number, the higher you are placed, it prefers to oxidize. In this example, it's between zinc and copper, so zinc. Done. Then, what reduces is always what is in the solution. What reduces is always in the solution. Therefore, H plus will go to H2. H plus will go to H2. That's it. Right? Then you can write equations. You can write equations like this. Zinc going to zinc 2 plus. That is the oxidation. We identified that it is the one which is oxidizing, and then H plus going to H2, which is the reduction. Simply, that's it. And then you can complete it by understanding what is the anode or what is the cathode. Anode is the rod which oxidizes. Cathode is the other rod. Complete. I kisi mawulak kanne for electrochemical cells. We'll answer some questions and check, confirm whether that is true. Kisi mawulak kanne nadda kiyala. Right? Right. Good. Yeah, actually reactivity series is shortened and given to which is enough for your questions. Exactly. Right. Yeah, Hari. Then what we can do is under electrochemistry, the first subtopic was electrochemical cells. All of us have written or drawn some small diagram. Then what we can do is we'll write a procedure from 1 to 2 to 3. We'll continue and write how to approach a question. Hari. If you want, you can put a small subtopic saying how to answer a question. Oh, how to answer a question. Then I'll give from 1 to 2 and I'll give you an order. Hari. While you are writing the order, try to remember it. Try to understand what exactly we are doing. Hari. Liamu. Ika. First one, we'll write. Reactivity series isn't hard to memorize. Yeah. I think if it is not hard, then that's good. And might not be for all. Hari. Just even shortened it. Hari? Yeah, the first one. Put the number 1 and write. Put number 1 and write. Identify what oxidizes using reactivity series. Identify what oxidizes using reactivity series. That's one. Identify what oxidizes using reactivity series. Identify what oxidizes using reactivity series, and then under that in brackets write identify what oxidizes using reactivity series, in brackets write anode. That's the anode. That's the anode. එකට තමයි අපි anode එක කියන්නේ. හරිද? That's the anode. Hari. Just put a bracket and write anode. Or else you can just write that's the anode. And then write the order. Now some of you might know the entire reactivity series, good for you. But if you don't, if it is difficult for you to remember, these are the ones which we need for the electrochemical cell part. Hari. Now of course, we can't remember the entire electrochemical series. For A levels, you need to know a little bit more than this. For O levels, this is enough for electrochemical cells. Sorry, මේ order එක ලියමු. Zinc, Fe, H2, copper. This is enough. Even if you want, you can exclude H2. මෙයාවත් අයින් කරගන්න පුළුවන් if you want. If you want, you can remove that. Because anyways, H2 won't be oxidizing. It's the metals, it's between the metals. And if you want, you can exclude this and just write zinc, Fe, copper. Up to you. ඕන්නම් පුළුවන්. Hari? Hari? So the first point is written. පළවෙනි එක ලියුවා ඔන්න. Right. Then second point. We haven't clearly written how to identify. So still the first point. The metal which is on top of the series oxidizes. The metal, still the first point, the metal which is on top oxidizes. The metal which is on top oxidizes. Hari. The metal which is on top oxidizes. That's one. Finished. Then the second point. metal which is on top oxidizes. Right. ඉවරයි. Second one over. Then put point number 2 and write. Point number 2 and write. The solution H plus in the solution will reduce always. Put point 2, it's very easy, nothing to learn. H plus in the solution will always reduce. 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 That's point number 2. Point number 1, point number 2. Then point number 3, write equations, write half equations, we call these half equations, isn't it? Write half equations and balance. Write half equations and balance. Write half equations and balance. Now it's very easy, there are only a very few amount of half equations we can expect. For the oxidation, it will always go from a metal to a 2 plus. If it is zinc, zinc 2 plus. Fe, Fe 2 plus. Now copper won't do it, but let's just assume copper 2 plus. And then you can easily balance. For hydrogen, this is the equation. H plus goes to H2, then you put a 2 here, and then I taught you how to balance it. Now if someone is too lazy to understand how that happens, you can just study the equation and write. But our purpose should be to avoid studying as much as possible. So what you would be writing for the reduction is this, not the entire studied equation, and then we will be balancing it. 2 hydrogens, put a 2. 2 plus, then put 2 minus by adding 2 electrons. And try to understand and do it. Then write half equation and balance. So no need to mention, no need to do anything here. If you want, you can write something. Now we are not here to prepare neat notes. Lassana note එකක් හදලා පිළිවෙලට ඒක නෙමෙයිනේ, we need a good short note, right? If you want, you can mention anything about how to balance if you didn't know. Simply, we write what happens and then we need to balance the number of atoms. Now for this one, nothing will be balanced, but here we had to put a 2 to balance it, and then we have to balance the charges by adding electrons. So I have showed a good example on how to balance it. Initially we didn't have this. So this is the, actually we have this only. First we'll balance the atoms by putting a 2 here. Balance the atoms by putting a 2 here, and then we'll balance the charges by putting electrons. Here the charge is plus 2, here the charge is 0, so we add 2 electrons to make it 0. Because the charge of an electron is minus 1 into 2 is minus 2. Plus 2 minus 2 is 0. If you want, you can try to understand. Right. If you want, you can write it. Or how to balance. And then the final point, the fourth one, the final point. Add the half equations to obtain the total reaction. Add the half equations to obtain the total reaction. Add the half equation to obtain the total reaction. That's it. Add the half equation to obtain the total reaction. Hari. We missed one thing actually. Ne podi deyak miss una mokadda? Matakada? What did we miss? Can you remember what we missed? Now we have written what is the anode. What was the anode? The rod that oxidizes. Then somewhere mentioned the other rod is the cathode. Rod oxidizes is the anode. The rod reduces is the cathode. Ne? Rod reduces නෙමෙයි. The rod oxidizes is the anode. The other rod is the cathode. Now I'll give you a small question to answer. Rod oxidizes is the anode. The other rod is the cathode. I even taught you why that is known as the cathode. Why? What's the reason? Why do we call that the cathode? Because that is the place where reduction happens. It won't reduce. Danda reduce when the rod won't reduce, but that is the place where reduction happens. That H plus going to H2 happens. Yeah, still we haven't learned why. You can hear or how to determine what is. Now you can hear no? YouTube level. You can hear no? Yeah, okay. Still we didn't learn how to determine what is positive or what is negative. How to determine the signs or the polarity of the anode and cathode. What is positive? Now most of you study it, right? For a electrochemical cell, anode is this, cathode is this. For a electrolytic cell, anode is this, cathode. Okay. I'll teach you that as well. Again, I'm saying, right, if someone prefers to study, if some parts you like to study, then understanding, why up to you? No need to just understand it because I ask you to understand. But for some, studying is very difficult, all of this. Then you can try to understand. Or you can use the hybrid method. Few parts I understand, few parts I study. Come on, sorry. Right. Here, what we are doing is, right, now before understanding the positiveness or the negativeness of a cell, of an electrochemical cell, for the anodes and cathodes, I'll give you a small, now you can keep like few rules in the note, because we'll be writing those as well. Rule keep and then I'll give you a separate question and try to answer that first. Mulim make answer karli. Try to answer this. Try to answer this question first. I want answers very quickly. You have a iron rod and you have a copper rod. You have iron rod and you have a copper rod. You have here diluted sulfuric. Okay, in Roman number 1, first you can draw this diagram. This is a question, right? Just to check whether you can remember things, whether you understood. First, identify the half reactions. Then write the total reaction. Total reaction. And finally mention what is the cathode, what is the anode. The only thing we can't do yet is identify what is positive or what is negative. That we'll do in a minute. Hari? Quickly do this, Lian. when you are switching between YouTube and Zoom, if you want, remember the YouTube has a 15-second delay, right? That's not our fault, it's how it is. All the YouTube lives are like that. Keep that in mind. Right? Hari, quickly finish this part. Quickly do this question. Taggala karan mega. I'll give you 3 minutes, maximum 5 minutes. Yeah, we are doing the question while summarizing. So still we haven't answered any parts of the question. This is actually the summary. It's like a hybrid. Dekama parallelly arang yanne me. Hari. Student has asked. So this slide is actually the note I gave you is the summary thing. Summary. What else? This is the summary. Now using that summary, if you understood the summary, try to answer this question. Then I'll do the same. Good, I am getting answers. Maru, them answers I'll answer this. And then I'll teach you how to determine plus minus without studying if you want that method as well using A levels. And then I'll do the same for electrolytic cells and then we'll start doing the question. Plan. Karan ban? Good, nice. I can see answers. Nice. Online, YouTube lamai also send answers to the chat. Send answers to the chat. Hari. I'll give you a few more minutes. I got the answers. I'll give you some time. The Zoom lamai, if you have serious questions, like if that question is answering that question is very important right now, you can send it through the YouTube chat. Right? I might not be paying that much of an attention to the Zoom chat. It's very difficult to handle that. Okay, I can see answers. Nice. Nice. What are the half reactions? Now shall I move on? First thing, compare these two and determine what is the anode and where oxidation happens. That was the first point. Now, then you have these two. What was the order? Zinc, Fe, copper. Hydrogen in the middle. That means zinc Fe is higher than copper, then Fe is the one oxidizes. Fe goes to Fe2 plus and 2 electrons. Fe goes to Fe2 plus. This is the oxidation. This is the oxidation. This is the oxidation. And if you want, you can, ions are always aqueous. Iron, Fe is a solid. We know that. It's a solid. So that's the oxidation. Where does oxidation happen? In the anode. Therefore, this is the anode. While answering, you can complete all. Anode. Oxidation always happens in anode. Doesn't matter whether it's electrochemical or electrolytic, oxidation happens in the anode. Then the second point, what did I say? Always diluted sulfuric, or the solution will reduce the H plus in that. Then this is always going to be the reduction. This is always going to be the reduction. Now I taught you how to balance this. You can even see I am not writing the total final reaction at once. I am writing H plus goes to H2 and then balancing. ඊට පස්සේ තමයි balance කරලා තියෙන්නේ. The Zoom chat is not disabled ළමයි මේ. If you can't chat through the Zoom chat, that means your Zoom is not updated. හරිද? මේ Zoom updates are a little bit crazy these days. හරි? If you haven't updated Zoom, you can't chat. It shows that the Zoom chat is disabled. මේ වන්න ළමයි අස්සන්න messages. හරි? Then you can use the YouTube thing, up to you. I don't know. Sorry? So this is the reduction. This is the reduction. Alright, that's step number 2. Then, so actually that's step number 1 and 2, and then we have written the equations as well. Alright, then you can balance these, you can add these in a way that make sure that these 2 electrons should cancel. You can see 2 electrons here, 2 electrons here. Once we add, those will cancel out. Alright. Then our final equation would be, the final one is 2H plus aqueous plus Fe solid goes to this side Fe2 plus aqueous plus H2 gas. This is our final equation. This is the final equation. See whether that is clear. On the final equation. This is the final equation. Isn't it? Hurry. And then one more thing was mentioned. What the other thing? What I mentioned? Can you remember? If this is the anode, then automatically this becomes cathode. Why does that become cathode? Because this reduction, reduction happens near this place, this area. That's why we call this the cathode. We call this anode because this oxidizes. We call this cathode because, not because this reduces. It can't reduce, but the reduction happens near me. The H plus going to H2. That's why. Right. So that's the complete question. So this is how we handle a electrochemical cell. Now I'll teach you how to understand what the positive end and the negative end is very easily. බලන්න කියලා දෙන්න ලස්සන. හරි? Right. කියන්න බලන්න. Wait, I'll teach the plus minus thing as well, and then we'll confirm whether all of you have understood this perfectly. Complete this, make ඉවර කරගන්න. Anyone who couldn't get the answers or who got the answers incorrectly, check what went wrong, why it is wrong. And I am repeating, if you have doubts related to subject, send a text to this number. I'll reply soon. Now I can't reply all of your messages. It's not possible. Then ඔක්කොම reply කර ඉන්න බෑ. මේ send a text to that number and I'll reply as soon as possible. Sorry. Okay, good. I'll give you 30 seconds more and then I'll explain quickly how the charges, how to understand what end is positive, what end is negative. Now I know most of you, maybe all of you just study it. There's a method to understand it. By 10 PM you will have a complete idea on both electrochemical cells and electrolytic cells. After teaching one, it's very easy to teach the other one. Okay, again. Hurry. wait. Abhiyang, observations වලට යන්න. Right. Before that, we need to know what are positive charges and what are negative charges. How to determine the charges of this. Sometimes they can ask. Now, these are the main questions they will ask. Apart from that, they can ask what are the observations we can see and mainly the charges. What is positive, what is negative. මේ බලන්න මතක තියාගන්න හැටි. Very easy. Very easy. මේ බලන්න. Now, what is the anode? This is the anode. This is the cathode. Now, why do we call it anode? Now, I am again saying, if you want, you can just study. Anode is this, cathode is this. Now, for this, I think the anode is negative, cathode is positive. You can study and answer. Up to you. But the issue with that is, it's not the same for an electrolytic cell. Then you need to remember it's the opposite. Whatever, if that is easy, kamak nahi thi. But there's another way to understand it. It happens like because of this method. We can understand it like this. Now, what does the anode do? Anode does oxidize. What is oxidation? Removing electrons. I'm repeating. Anode oxidizes. What is oxidation? Removing electrons. Removing. You have electrons, you are sending those away. You are pushing it. Then this is cathode. What is cathode? The reducing one. The reduction happens near it. That means accepting electrons. You are accepting the electrons which is given by the anode. So this is the direction of electron flow. Now tell me, do electrons like positive charges or negative charges? Someone answer. Do electrons do electrons like negative charges or positive charges? Positive charges, right? Why? Electrons are negative itself, then it would like the opposite charge. Normally, that's how it works, right? Electrons are negatively charged, therefore it does prefer positive charges. Then, now look at how the electrons are attracted. Electrons are getting attracted towards this side. Electrons are getting repelled. Electrons are going away from this side. That means this side is positive, this side is negative. That's one way of remembering it easily. I'll repeat. Now already we have understood this is the anode, this is the cathode. Anode is the one which oxidizes. Oxidize means removing electrons. Electron pita karana. Cathode is the place where reduction happens. Reducing is accepting electrons. Electron ganna. And what we know is generally electrons prefer positive charges because electrons are negative itself. So it likes positivity. Then this is positive. Kamati pattare and it prefers positive ends. It doesn't like the negative end. That's why it's going away. So easily you can remember what is negative and what is positive. No need to remember. For every question you can very quickly within like 1 second you can think that entire thing and quickly mark the negative end and the positive end without studying. If you want you can study it, up to you. Right, that's the idea. You can mention that. Now I'm not giving a note for that. You can mention how we thought. Hitapu vidhiya liyanna. Try to turn it, try to convert it to your own words. Anode is this is the anode, oxidation happens here which is pushing electrons out. This is the cathode, reduction happens here which is accepting electrons in. So this is the electron direction. Electrons are approaching the positive end because it likes the positive end. Electrons are going away from the negative end because it doesn't like the negative end. You can write it on your own words. In your own words you can write it, up to you. Right. That is how we get the answer. Now I am not going to give a note for that. Now you are experienced enough in all levels not to write everything given by the tutor. Now you should be able to write a note in your own words and explain how to determine negative and positive. Use those small shortcuts to reduce the amount you study because you have a lot of other parts to study. Right now for biology you have things to study. You may have study karan never. Understand what happens. Okay. Okay, that's it. In case they ask for an observation, you should always look at these equations and try to write something. It's not that difficult. If they ask for an observation, what can we observe in this cell? You can see Fe is going to Fe2 plus, which means slowly the Fe is reacting. That means with time we can see this rod reacting. This rod is reacting, and you can see the rod start to react. With time you can see the size of the rod decreasing easily because it reacts. And also you can see a gas being produced. H plus is producing H2. Where does that happen? Near the cathode. So you can see near the cathode air bubbles, right? You can see some bubbles here. When a gas is produced, you can see some bubbles near the cathode. Right? So you can write those observations if they ask. No need to study separately the observations from cell to cell. Always look at these and determine. Now always you can see the anode size decreasing with time because anode oxidizes. And always near the cathode you can see air bubbles. That's it. Right. Now can you confirm whether you understood all the ideas? Yeah, H2 liberated is also fine, but that's not a proper observation because when the gas is liberated, it doesn't have a label saying I am H2. So you can say a gas is liberated or a gas bubbles are shown, but writing H2 is fine, but practically it's not the perfect answer. Yeah, කට්ටිය තේරෙනවද කොහොමද තත්ත්වය? Is it fine? අවුලක් නැද්ද? Shape ද? Are we all good? YouTube ළමයි කොහොමද? Can we understand? Shape ද? Up to now? තේරෙනව නේද? Right, nice. Sorry. So that's the electrochemical part. Now if you want, I'll give you like 2-3 minutes. I'll give you 2-3 minutes. Like 2 minutes. Quickly revise what we have done regarding the electrochemical cells. Now that's around 30% of your electrochemistry part. Sorry. But the next 30% will be finished very quickly. Then you have a certain idea about this now. ටක් බලන්න. About electrochemical cells. I'll give you 2 minutes. At around 10, we will be finishing the electrolytic cell as well. The total reaction you want me to explain, it's just adding these two. I have just added these. Making sure that these two electrons are getting cancelled. You have 2 electrons on this side, you have 2 electrons on this side, so those two get cancelled and everything else has been added. That's it. Is it difficult? That's how we got it. This and this will get cancelled, everything is added. Fe 2H plus Fe2 plus H2 නිකන් add කරලා තියෙන්නේ. Hari. Again. Now, hari ne? The half reactions. What was the issue with the half reactions? Now I don't have time to explain the entire half reactions part. I think you will have to go back and check. It takes a little bit time ne? Hari. Then next, now this is the electrochemical cell part. Sorry, now we are going to learn the electrolytic cell. Put the next topic and write electrolytic cell. Electrolytic cell. Or electrolytic cell. Taggala hagan, hondra hagan. Electrolytic cell. I'll be doing it very quickly. Hurry. For the electrolytic cell, again, the diagram looks a little bit similar. The only difference is we have a battery. That means the reactions we are writing here are not natural. It's being forced. So the battery can force the reactions in this cell. For an electrolytic cell, it's forced. It's like the opposite of the electrochemical. Now after learning this, we'll have a small table and compare the differences between electrolytic and electrochemical as well, which will be very important for you. Hari. Now here what happens is, again you have two metal rods. Hari. And not metal always. Now in your case actually, in all the electrochemical cells, electrolytical cells, this is carbon for you. Carbon no platinum. Hari. Now again don't write anything. First we'll understand quickly. And then we'll write a short note for this. Carbon or platinum. That means it's inert. Always these rods are inert in your syllabus. It's not true in the actual case, in the real world. In A levels we'll learn some rods are not inert. But for you in O levels, both the rods for electrolytic cell is inert. So no need to worry about those. So all the attention is in the solution. We are only paying attention to the solution. Is that clear? We are only paying attention to the solution. Then, what happens? It's again very easy. So both the anodic and cathodic reactions, all the competitors or all the options are in this. Make ඇතුලේ තමයි තියෙන්නේ. හරිද? ඔක්කොම options ටික තියෙන්නේ මේක ඇස්සේ. තේරෙනව නේද? All the options are in this. Then what happens is this. මේ බලන්න. There aren't many options for us. For the reduction, for the reduction, these are the options we have. We have Na plus, we have H plus, and we have copper 2 plus. These are the only options for the reduction. For the oxidation, these are the options: OH minus, Cl minus. It should be the opposite: Cl minus, OH minus. These are the only options. Now, this is not a random order. This is again a simplified version for you to make your life easy. So for the reduction, there are 3 competitors. These are the arrangements: 1, 2, 3. So in a solution, if you have it should be the other way. I'll change this as well then. OH minus, Cl minus. So these are the competitors, and this is the way you need to remember this. 1, 2, 3. What does that mean? That means in a solution, if you have both copper 2 plus and H plus, copper 2 plus will reduce. If you have both H plus and Na plus, H plus will reduce. If you have only copper 2 plus, still it will reduce. If you have only H plus, still it will reduce. If you have all of these 3, this will reduce. Again, these are the 3 competitors for the reduction. Now I am just summarizing all your notes. These are the 3 competitors for the reductions, and then this is the best one. This likes the most to reduce. If you have this and this, this will reduce. If you have this and this, this will reduce. If you have this and this, this will reduce. If you only have this, it might not like to reduce, but it should reduce. It will reduce, can't help. Same here. This is first, this is second. If you only have OH minus, it will oxidize. If you only have Cl minus, anyways it will oxidize. If you have both, Cl minus will oxidize. So it's very easy. It's very easy to remember. That's the summary. All of you should remember that. You should be remembering that. So for an electrolytic cell, it's very easy. You only have 5 things to remember to answer all the questions. For the reduction, this is the order. If someone wants, you can put copper 2 plus, H plus, sodium plus, and right up to you. For these two also, you can do the same. Cl minus, OH minus. I have just written it the other way. I don't know why. I just feel that was better. Right. What we are doing is, when they ask a question from us to determine and write the equations, it's very easy for us. Now for an example, I'll just take a random one. Now still don't write anything. We'll just answer one question and see whether we can do it properly. Now in your syllabus, I'll take a random example. They are saying electrolysis of copper sulfate solution. Electrolysis of copper sulfate. Now I took a random example. Not prepared. Electrolysis of mono copper sulfate. The aqueous copper sulfate. Aqueous copper sulfate. Right. Now they have given you a diagram. It's like this. You have copper sulfate here, which means copper 2 plus and sulfate. You know how to break down this, right? Copper 2 plus and sulfate. And then since it is aqueous, you have water, which is H plus and OH minus. You know that as well. And then we don't bother about these rod. Why? These are all carbon. We don't care. Those are inert. And then you have a cell. This diagram will be given. Normally they give the idea. Now in the question, we were looking at question number 6 also. The diagram was given. Now they ask you to write the oxidation. Very easy. What are the options for the oxidation? Sodium plus, H plus, copper 2 plus. What has the highest priority? Copper 2 plus. Or else we can read the list. Copper 2 plus, H plus, sodium plus. Copper 2 plus has the highest priority. Now, that order. Then, so what's the order? For the reduction, oxidation, that's for the reduction. Then we'll do the reduction first. For the reduction, what's the order? Copper 2 plus, H plus, sodium plus. This is the order. Now what do we have at the moment? We have both copper 2 plus and H plus. So what is the priority? Copper 2 plus. Then what's the answer? Copper 2 plus goes to copper. Now you can balance this. Copper is a solid. Ions are always aqueous. 2 plus, then we need 2 minuses by adding 2 electrons. Done. Done. Reductions are over. What about the oxidations? Lamai? For the oxidations, what happens? Oxidations, what are the competitors? For the oxidations, it's OH minus and Cl minus. Cl minus is the best. Then we have OH minus. But here we don't have Cl minus to look at. Then it's only OH minus. OH minus normally oxidizes to O2. OH minus normally oxidizes to O2. Now I know most of you will try to remember this equation, the balanced equation. Just remember OH minus goes to O2. Balance. Balance. How to balance this? Now balancing something like this is very easy, right? Make a balance. You have 2 oxygens on this side. So we need to make this 2. The only way we can't put a 2 like this. That's not how we balance the equations. You have 2 oxygens, so you have to put a 2 like this. Now what's the issue? Now the oxygens are balanced, but on this side you have 2 hydrogens. Then you need to have 2 hydrogens on that side. For that, we can't just add H2. The only things we can add is H plus. You can't add H2. So it's 2H plus. Now how to remember the charges? No need to remember the number of electrons. Here the charge is minus 1 into 2, minus 2. Minus 1 into 2, minus 2. Here the charge is 0 into 2, 0. Here the charge is plus 1 into 2, plus 2. What's the difference? Here it's minus 2, here it's plus 2. Gap 4, minus 2, minus 1, 0, plus 1, plus 2. The gap is 4. 1, 2, 3, 4. Then you need to add 4 electrons to reduce the gap. Then hurry the balance. See whether the charges are balanced. Plus 1 and plus 2 and minus 4 is minus 2. So if you always try to remember these balanced equations, which is difficult, Try to understand how to balance. It's very easy. OH minus, so the white color ones are the ones we need to remember. The yellow colors ones are the ones we balance actually. Then you can put the physical states. Ions are aqueous. Oxygen is a gas, of course. We know that. That is the idea. So OH minus goes to O2 and H plus and 4 electrons. That's the balanced equation. So we picked a random cell and it's very easy for us to balance. Balance karana lazy neither. It's not difficult and they don't normally expect you to write the complete equation. If you want to write the complete equation, again you can add these two and write the equation, but that's out of syllabus. I think so, because the number of electrons are not similar. Then in A levels we learned, we multiply this equation by 2. Then what happens? This becomes 4 electrons and then there's 4 electrons, so you can add and get the balanced equation, but no need for O levels, I think. Yeah. Okay. I'll explain that part now. Now some of you know, some of you are already asking, isn't it H2O instead of OH minus? Yeah, that's a extension of that. Now most of you have just studied it, I think so. I'll explain how to even get that equation without studying. I know that. Wait. But this is the first step. Now of course we in your textbook, if you check, and most of you might know, it's not OH minus, we write it at H2O. I'll explain why in a minute. Before that we'll prepare our note. Then we understand how to handle electrochemical cell, electrolytic cell. It's very easy. Very few things need to be remembered so that we can answer any of the questions. Right. Write the topic electrolytic cell. Electrolytic cell diagram. If you want, again you can draw a small diagram, and the typical diagram would be, there would be a battery here and then these two rods will be carbon or platinum, so we ignore those. All the attention will be given here. If you want, you can draw one. Later we might use it to determine the signs, negative, positive or not. We might use, so draw a small diagram. Yeah, we'll write the note, then you get a good idea. I no need to separately repeat it. And then again we'll follow a small procedure, stepwise procedure. I am feeling that we might not have some time to cover the corrosion part. If I want, I can rush the process and cover it. But that's not why you are here. Most of you have issues related to these processes, so it's not just somehow completing the lesson. Therefore, I'll go in this space, continue in this space. In case we are running out of time, I think last year also this happened. In case we are running out of time, we'll see what we can do for the corrosion part. Still we have around 1 month left. We have time. We'll do something for that. Yeah. Don't think about it now. We'll continue in the pace. We are continuing. Procedure. If you want, put electrolytic cell and draw this diagram and mention carbon and the battery if you want. That's how we identify whether it's electrolytic or electrochemical. Simply, if there's a battery, it's electrolytic. If not, it's electrochemical. That's also important. If you get it messed, then you are getting the entire question wrong. Right. Then procedure 1. Procedure 1. ලියන්න. එක කියලා දාලා ලියමු. Identify the reduction reaction. Identify the reduction reaction. Identify the reduction reaction. Now I am not giving you answers for questions, right? I am proposing a method. So you can answer any of the questions. එකකින් එකට වෙන වෙනම උත්තර මතක තියාගන්න ඕනේ නෑ දැන්. හරි? First one, identify the reduction reaction. So what are the competitors? Then write the competitors. Shall we go the other way? Identify the reduction reaction. This is the order. This likes the most to reduce, this likes the least to reduce. You can mention it. So these will reduce to, this will reduce to copper, this will reduce to H plus, this will reduce to sodium. Anyway, this prefers the most to reduce. You can mention it in a way you prefer. The first one, identify the reduction reaction, and this is the order. Copper 2 plus is the best, Sodium plus is the worst. So if we have more than 1, we should use this priority order. Hari? Now there are some questions asked about this equation, whether it's for OH minus or all. Wait, don't panic. There are few corrections we need to make. We'll discuss it later. I think the session will be continued until around 11. Okay, so if you have another class, you can watch the last part later. That's the reduction. Hari neda? Can you write the note on your own? Awulak naha neda? Puluwan neda? Is the first point clear? Can someone confirm whether you are okay with writing the note? Shape neda? Awulak naha ne? Right, good. Hari, okay. Then, point number 2. Identify the oxidation reaction. 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 Nice, okay. What are the competitors? Cl minus and OH minus. Cl minus is better than OH minus. This is it. Then what do these oxidize to? Cl minus oxidizes to Cl2. OH minus oxidizes to O2. Mention this. Hari. Cl minus going to Cl2 and OH minus going to O2. That's the oxidation. Now the next part. Now up to now I have taught. Check whether everything is fine, and we did a small example and check whether we are okay with it as well. I'll also give you a question to do. Before that we'll finish the other parts as well. Now again for this cell also we need to identify what is the anode, what is the cathode, and the respective charges. Plus minus we need to identify. We need to identify the respective charges as well. For that what we can do is this. For that what we are going to do is, again I am using the idea of electrons. Now can you remember in the last question, the last electrochemical cell part, we used the idea of oxidations and reductions and drew the electron flow and tried to identify what is plus, what is minus. But the issue is there we knew what the anode was. Anode now we don't know out of these what are the anodes. Why? Because both the oxidation and the reduction happened here. Then what we are going to do is we are using this cell to determine what is the anode, what is the cathode. So it's very important to know which end is positive, which end is negative in the cell. You know the longer end is positive, the shorter end is negative. Now can you tell me, now Now I am not giving the answers. Now I will get the answers through you. මම ඕගොල්ලන්ගේ කටින් උත්තරේ ගන්න හදන්නේ, right? Tell me from which end to the what end does the current flow in a cell? ටක් ගාලා කියන්නේ is it from the මේ I කියන එක නා current එක යන්නේ from the positive end to the negative end or is it from the negative end to the positive end? Quickly tell me. Which direction does the current flow? Is it from the positive end to the negative end or the negative end to positive end? Tell me. Yeah, it's positive to negative, right? Very easy. It goes from the positive end to negative, right? Then, may balan. Current flows from positive end to negative end. This is the direction of current flow. I don't know whether you have learned this. Maybe you might have. We define the electron flow is the opposite direction. Now, I'm again saying, for some, this might be totally a disaster and some might just prefer, okay, it's fine, I'll just somehow remember. Then the issue is you will have to remember this for every cell. But what I am going to teach is using A levels, I am teaching you a method which will make it easy for all the cells. So the first thing is what we know is, the thing we know is, from positive end to negative end, current flows. That means electrons flow in the opposite direction. So current flows like this, then electrons flow the other way. So this is the electron flow. Looking at the battery, we can mark the electron flow. Looking at the battery, we can mark the electron flow. Now I'll give a note for this because this part is new for you. Now you can easily determine the cathode and anode. How? Revise what we did previously. If electrons are going outwards, that means electrons have been pushed. I don't want electrons. What is that? That's oxidation, right? So this is oxidation. This is oxidation. Therefore, this is the anode. Therefore, this is the anode. Accepting electrons, that is reduction. Therefore, this is the cathode. See how easy it is now? Without knowing what happens, you all just studied, right? This end is anode, this end is cathode. Now you know what happens. Using the battery, current flows this direction, anti-clockwise. Then electrons flow the other direction. And then you can see electrons are going away. That's oxidation, anode. Electrons are coming to you. That's reduction, cathode. Then also, how to determine the charges? Here, it's very easy to determine the charges. If this end is positive, this is positive. If this end is negative, this is negative. That's how it works. That's it. Because the cell determines for an electrolytic cell, cell charges if this is positive, this is positive, this is negative, this is negative. That's how we get the charges. So no need to really remember. That's how we determine the charges. So I'll repeat. From positive end to negative end, current flows. Now we are not remembering these. We know those. From positive end to negative end, current flows. Then the electron flows the opposite direction. Then you can see electrons are going out, electrons are coming in. Then going out means oxidation, that means it's anode. Electrons are coming in means reduction, that means it's cathode. If this end is positive, this end is positive. If this end is negative, this end is negative. That's how we get it. See, you can understand it, right? That's how we get it. See how easy things are actually when you know what happens. That's why even last time I said A levels can be difficult, but we know what happens actually instead of just memorizing everything out of nowhere. Okay, shall we write down that? Now we have written how to identify reduction, how to identify oxidation. Now we need to identify the anodes and cathodes. Put the third one and write identification of anodes and cathodes. I'll give you a small note for that. Identification of anodes and cathodes. Identification of anodes and cathodes. Now these days you might be a little bit tired, you might be having some seminars, maybe some of you might have a lot of classes. Manage you have like 1 month left for your O levels. Right? The only point that which is good, the student has asked a very good question. Hari. Now in the last one, can you remember I told that electrons get attracted to the positive end, but here can you see the electrons are getting attracted to the negative end? Hari. For the moment, don't think about it, right? I know the answer, but for O-level students, it's difficult. Hari. So that's the only thing which is not, which doesn't make sense. Hari. Now you can see that's a contradiction, right? In the last one, I told you to remember that electrons get attracted to the positive end. That's the way I told you to remember. In this method, we are using a different method, but the issue is now you can see electrons are getting attracted to the negative end. There's an explanation for that, but it's not in your level. If it was A level, even that could have been solved. I think. Unfortunately, you will have to remember that. The minimum. Good question though. Yeah, leave. The third one. Identify the cathode and anode. Identify the cathode and anode. Now we need to follow a sequence. We'll follow the sequence. What is the sequence we need to follow? Identify the cathode and anode. What is the sequence we need to follow? Shall I use a separate diagram for this? Hari, Agan. Identify the cathode and anode. Here's what happens. The first thing is, now sometimes even reading the note might not give you a clear idea. So you need to visualize what happens. The first thing is considering the charges on the cell determine the direction of current flow. That's the first one. Considering the charges on the cell determine the direction of current flow. That's number one. You can write it in an easier way if you want, up to you. Considering the charges on the cell determine the current flow, direction of current flow. That's number one. That's number one. Considering the charges of the cell determine the direction of current flow. Make it anti-clockwise. Hari. Then the second point is electrons will be flowing in the opposite direction. Electrons will be flowing in the opposite direction. While you are writing, you can complete your diagram. Electrons will be flowing in the opposite direction. Current this direction, electrons this direction. Electrons will be flowing in the opposite direction. Electrons will be flowing in the opposite direction. Then what happens? Focus. Then what happens? The third one you can write. How are we going to write that? That's a method. You can see here electrons are going away, electrons are approaching the rod. Electrons are going away. Electrons, now you can even mention this is going away if you want. Electrons are going away from the anode. Why? Because that's oxidation, right? Electrons are going away again, oxidation. Electrons are going away from the anode while electrons are approaching the cathode. Electrons are going away from the anode while electrons are approaching the cathode. Sorry? Electrons are going away from the anode while electrons are approaching the cathode. Electrons are going away from the anode while electrons are approaching the cathode. Very easy name, eh? Going away means oxidation, approaching means reduction. We are collecting electrons, so this is the cathode, this is the anode. That's the third point. Fourth and final point. And you can mark the cathodes and anodes as well. Huh? Now this you can see electrons are going away, so this is the anode. Electrons are coming, so this is the cathode. That's the point 3. Point 4. Charges. Charges නෙමෙයි නේද ඒකට කියන්නේ. කවන්නේ. The poles වගේ තමයි ලියන්නේ කවන්නේ charges. Yeah, that means the cathode is reduction. Yeah, always cathode is reduction. That's why always cathode is reduction. That's why when we can see a reduction, we call it the cathode. When we can see oxidation, we call it the anode. Now we actually understand what really happens here instead of just studying. Then final one, charges. For charges you can write. For charges, right? Charges on cathode and anode. Charges the final one. Positive end of the cell is connected to the positive end of the cell gives a positive charge to the rod. Negative end of the cell gives the negative charge to a rod. Clear? That's easy. Or else you can just say this positive end connected rod becomes positive, negative end connected rod becomes negative. Even that's better. Up to you. Positive end connected rod becomes positive, negative end connected rod becomes negative. Now here we are not focusing on writing the note properly. Our goal is to understand and answer questions. Positive end of the cell gives a positive charge to the rod. Negative end of the cell gives a negative charge to the rod. ඒ වගේ එකකුත් කමක් නැහැ. හරි ඉවරයි. That's it. Done. කොහොමද දත්තේ? Shall we do a question and see? Up to now is everything fine? තේරෙනවද ළමයි? දැන් දෙන්න බලන්න feedback එකක්. Now we have finished almost all of electrochemical cells and electrolytic cells. Now it's up to us to do some questions and see whether this is good, whether the idea is solid now. තේරෙනවද? Zoom එක ළමයි කොහමද? අවුලක් නැද්ද? තේරෙනවද? Shape ද? Are we doing well? We have around 50 to 1 hour left, 50 minutes to 1 hour left. Shape එකේ ගේමක් ගහගන්න පුළුවන්. Zoom ළමයි කොහමද තත්ත්වය? YouTube ළමයි තේරෙනවද? Understood නේ? කොහමද තත්ත්වය? දෙන්න බලන්න වීඩියෝ එකක් පොඩි. I didn't understand the fourth point. Yeah, it's very easy. That's the easiest one to understand. There's nothing to understand. If the rod connected to the positive end of the cell is positively charged, rod connected to the negative end of the cell is negatively charged. Now how? There. Again, rod connected to the positively charged cell is positive. May negative end connected, this is negative. That's it. Right. Nice. I'm assuming that all of you are understanding this perfectly. Because I am giving my maximum. Because in reality I am not getting anything, I am not gaining anything by doing these seminars. I just believe that it's good to help you. We did this last year and it went well, so just thought of having it this year as well. So it's your responsibility. Let us know. Nice, good. Right, then what I want you to do is I'll give you a small question again, like a model question. I'll give it now. You can read the electrolytic part and then try to answer that, and then we'll look at the actual past paper questions. Right. Right, while we are doing past paper questions, before that, main issue, we need to solve this as well. Now in this equation, there were some concerns. Some students said that this equation is wrong. Actually, it is wrong. Why is it wrong? Mega varadi wenna hetuwa thamai the reason. Now I'll teach you the reason as well. Now it's given in your resource book. It's given podi assaka dila thiyena. The reason why this reaction is wrong is only the reaction where we use OH minus. All the other reactions are fine when I OH minus. Now can you remember in the beginning I said H2O is H plus and OH minus. Wherever we see H2O, we write H plus and OH minus. So instead of now, why did we write H plus OH minus here? Because it's aqueous. Aqueous means water. Now instead of H2O, I wrote H plus and OH minus, which is wrong. In chemistry, that's wrong. Now, in O levels, you might not know exactly the difference. But H2O is not H plus and OH minus. Now, if you take a sample of water, a very small amount of H plus and OH minus is there. All the other water molecules exist as H2O. It doesn't exist as H plus and OH minus. And ඇත්තට වතුර ගත්තොත් H2O ගත්තොත් මාර පොඩ්ඩක් තමයි H plus and OH minus විදියට කැඩෙන්නේ. A very small amount dissociates as H plus and OH minus. The entire other moles are H2O. Then it's wrong representing H2O as OH minus or H plus. එහෙම ලියන එක වැරදි. හරිද? But what we do is this. මෙතන අපි කරන්නේ මේක. If we write here as H2O, it's difficult to balance, in my opinion. So what we do is whenever we find H2O and even to get H plus here, whenever we get H2O, whenever we get H2O, we just ignore the actual idea and write it as H plus OH minus. අපිට H2O ආවම අපි ඕක හිතන්නේ නැහැ. අපි නිකන් H plus OH minus කියලා ලියනවා. We just write it as H plus and OH minus. It's fine. Then after writing the equations, we need to correct ourselves. මුලින් වැරදියට ලියනවා. හරිද? මුලින් වැරදියට ලියනවා. And then we correct ourselves. කොහොමද correct කරන්නේ? මේ බලන්න correct කරන්න හැටි. Now tell me someone, OH minus writing here is wrong. Now don't really try to focus on why OH minus is wrong. Now I told you that if you didn't understand, that's fine. Just understand writing OH minus or H plus in our reactions where we have water is wrong. Hema water වෙනකොට you can't write H plus or OH minus. එහෙම බෑ. හරිද? Then we need to convert this OH minus to H2O. How do we do that? Now wherever you have a OH minus, if you can add a H plus to that, it will give us water. හරිද? Now we have two OH minuses here. So what we do is we add two H pluses. We add two H pluses. Can we just add two H pluses to this side and say that's correct? No. Why? Already this equation is balanced. So if we are making it imbalanced, then we need to do the same to the other side. Otherwise the reaction won't be balanced anymore. So having two OH minus is wrong. We need to make it water. So we need to add H plus to make OH minus go away and make it water. Hurry. Since you have two OH minuses, you need to add two H pluses. Hurry. But you can't just add two H plus because then the reaction isn't balanced. Then we need to add another two H plus to this side. We need to add another two H plus to this side. Then what happens? This becomes two water. Hurry. This and this becomes this. Goes to O2. You already have 2H plus. This 2H plus will become 4H plus and 4E. This is how you actually get that equation. Now instead of just studying, you know exactly H2O is liquid. It's not aqueous, it's liquid. We write it as. Now you know exactly how or why we do that change. So my recommendation is forget about that and first write this and then correct yourself. So this is the correct answer. That's why it is given in your resource book. Hurry. So some sounds are coming. Isn't the audio clear? Yeah, podi sabdayak enawa ne. Yeah, wait, I'll check that. I'll solve it. Hurry, hemit hada damu. Okay, hurry, complete this. Dagamu meka. Okay, now did that sound go away? Is it fine? Didn't get electron and current flow. Okay. 2 oxygens නෙමෙයි. කොහෙද 2 oxygen? නෑ මේ හරි. This is correct. Alright, okay. Current flow and electron flow was current flow යන පැත්තට විරුද්ධ පැත්තට the opposite direction electrons flow. හරිනේ? Right. Okay. I think that's solved now. හරි. Okay. Right. Here now that is the correction we make. Now I'll repeat again briefly. Having OH minus is wrong, you need to convert it to water. What we do is we add H plus. Since we have 2 OH minuses, we add 2 H pluses, making it 2 water. But we can't only do it to this side, we need to do it to the other side as well. Ekai, you get 2H plus and this 2H plus as 4H plus. Right. Now have they done it for H plus as well? Yeah. For the cathodic reaction also they have done it. For the reduction for the cathodic reaction also they have done it. Methanat, in case, now I'm not, in our example we didn't get it, but in case, now this is the priority order. In a question you don't have copper 2 plus. Then what will reduce? H plus. What will reduce? H plus. If you don't have copper 2 plus, now in this question we have. But if you don't have copper 2 plus, H plus will be the answer. Then what happens? H plus goes to H2 is the reaction. So we write 2H plus and then we write 2 electrons and balance. Now is this correct? No. Why? The same reason. Instead of water you can't write H plus. Then again what should we do? We should change. We should correct our mistake. අපි අපේ mistake එක correct කරගන්න ඕන. How to correct? By adding now H plus. If you had OH minus, we can add H plus and make it water. If you have H plus, we can add OH minus and make it water. We add 2 OH minus, but you can't do it to this side. You only to this side. You need to do it to both sides. Then 2 electrons plus this and this 2 water goes to H2 plus 2 OH minus. That is how that is given. Now in your textbook they have just mentioned it is correct to write this than this. Now you know exactly why and how to convert it from here to here instead of remembering it. When I was doing A-level, always I remembered it. They had given this is better than this, so we had to remember this. The actual idea of that, what happens is you convert this H plus by adding 2 OH minus to make it water. That is what happens. Okay. So for this also it can happen, right? For H plus and OH minus both it will happen. So my recommendation is first don't think about that. First write it as H plus and OH minus whenever you have water. Then accordingly select what will reduce and what will oxidize. And then if you have H plus or OH minus in your reactions, convert those to water. It should be 4 OH minus. No, this is correct. 4H minus නෙමෙයි. These two equations are correct. This is perfectly correct. This is one correct equation. This is the other one. This is one correct equation. This is the other correct equation. Sorry. This is correct. These are two correct ones. How to figure out what to add? I think it's obvious. How to figure out what to add is obvious. When you have H plus, you need to add OH minus to make it water. When you have OH minus, you need to add H plus to make it water. What's that? Sorry? Okay, so that is it. That is the whole summary for electrolytic cells and electrochemical cells. The only part I haven't covered related to electrolytic cell is the part called electroplating. There's a small idea about electroplating given. It's like, now you might have seen the imitation jewelry where they have some metallic thing and we paint gold or paint silver imitation කියනවානේ, or else we call it gold plated, silver plated. That's electroplating. Now you might have seen some cars which are gold plated. That's electroplated. In ships we do the electroplating thing. That's related to electrolytic cell, which need to be a little bit more taught. Hari පොඩ්ඩක් කියලා දෙන්න තියෙනවා ඒකේ. Other than that, everything is over for electrolytic cells and electrochemical cells. පැහැදිලිද? Right. And shall we move on to some questions? Shall we try to do the sixth question on our own? Now for the six, all of this data isn't enough. I mean, all of this theory isn't required, but now you know everything. To have a start, පොඩ්ඩක් try කරමුද? While we are answering the questions, I'll give you some ideas as well, some more theory. Now at the moment, if you want, you can take 1 minute and go through the entire note. We have revised electrochemical cells and electrolytic cells. ඒ දෙක සම්පූර්ණයෙන් revise කරලා තියෙනවා. Initially my plan was to do some questions while revising, but at the last moment I thought of just using the method we used for unit 3, not unit 3, the chemical calculations part. හරි ඒ විදිය හොඳයි කියලා හිතුණා. So I revised the electrochemical and electrolytic cells because I felt that most of you have issues. Hari, what can we use as solutions? Why can't we use alcohol and distilled water as solutions? Distilled water we can't use because it won't give a lot of ions. Normally, that's one thing. Water is not a good electrolyte. Electrolyte is a thing which has a lot of ions, which can give a lot of ions. Water can't. Hari, just answering few random questions here and there. Yeah, anyway, Hari, shall we try to answer the question 6 and බලා ගන්නකො. The cell U shown below is an electrochemical cell. Now do they need to mention that? No, because cell U doesn't have a battery. You should know it's a electrochemical cell, and cell W is electrolytic. You should know that because it has a battery. ඒව දැක්කම තේරෙන්න ඕනේ. හරි? Okay. And then regarding cell U, they have given zinc electrode, copper electrode, dilute, sulfur, the things we discussed, right? Regarding the other one, carbon, aqueous copper, again, I think the same one I took, ne? Ekamane? Hari. In which cell above is chemical energy converted to, right? Now, for an electrochemical cell, electrochemical කියන්නේ අපි මුලින් ඉගෙන ගත්ත එක. Electrochemical and electrolytical cell. The first thing is, this doesn't have a battery. Now just for your understanding, I'll write something. See whether you know this. Doesn't have a battery. Reactions are, we call it spontaneous or happens automatically. Ne? Automatically. We can't force it. We don't have a battery. It automatically happens. In an electrolytical cell, it has a battery. So the reactions are non-spontaneous, or else it is forced. We are forcing the electrons, the reactions. That is one. That means, now what happens is, in an electrolytic cell, a battery is added and that battery tells what chemical reactions should happen. So the battery has electric energy. That energy is used to do some chemical reactions. Then in here, the battery has electric energy, which is converted to chemical energy. Chemical reactions will happen. But here what happens is the other way. I told you, using an electrochemical cell, if you want, you can even lit a bulb. Ne? Then here, using the chemical reactions, we can produce electric energy. We can produce electricity. That's why we can light up a bulb if we want. Right? That is the. So chemical goes to electrical here. Electrical energy goes to chemical energy there. If you want, you can again study, but have a brief idea on why that is. Here you have a battery. So the battery produces electrical energy that gives chemical energy. Here, the electrochemical cells have chemical energy which is transformed to electrical energy. That's why we can light up a bulb. If you want, you can produce that's why we call it in real life, we call this a battery. Actually, electrochemical cells are the batteries we use. Those will generate energy. Okay. So the first one asking, in which cell above is chemical energy converted to electrical energy? In which cell? This one, electrochemical cell, or else cell U, cell capital U is the answer. Cell U is the answer. Now this question is a good one. It is a mixture of both. You need to know about both the cells. If you want, you can write down this. Now the note part is over. We have prepared the short note for electrochemical and electrolytic. Now we are answering the question, so you can do it separately. While answering, if we learn something new for theory, you can put it in your note as well, add to the note. Up to you. We have around 35-40 minutes left. I will continue until 11:10 maximum. And if you are very interested, if you want, I can even give a small session for corrosion of metals, or as I can send a recording. We'll discuss whether what we can do after finishing this part. Right. Then part number 2. What is the name by which the anode reactions occurring in two cells are known in common? What is the name by which the anode reactions occurring in the two cells are known in common? Mokadda? Anode reactions, what do we call? What's the common name we call the reaction that happens in anode? Is it even a difficult question? Man, it's very easy. Mokadda kiyanne? What do we call? For the anode reactions, what do we call? Oxidation, nice. We call it oxidation, isn't it? Lazy, right. So Roman number 2, the reactions happen in anode is known as oxidations. Very easy. So I'll answer it here. Roman number 1, it's cell U. Roman number 2, it's oxidation. Okay. Roman number 3. Indicate the half reaction occurring at anode of cell U by a chemical equation. Now very easy, we have learned those. Now quickly think, cell U is electrochemical, the first one we learned. Electrochemical, for the anode, what should we do? We should remember that order. Matakada order for electrochemical cells. Now if you can't remember it right now, it's fine. We just learned it. Go through your note, maybe 1 page, 2 page, maximum 3 pages for the entire unit. Right. Here, for the cell U is electrochemical, that means what the order? Mokadda order එක මතකද? Sodium, then we have iron, then we have copper. Hari. What do we have? Sorry. මේ මොනවද? Zinc, sodium. Zinc, we have iron, then we have copper. Hari. Then for the anode, what do we have? Here we have zinc and copper. Hari. What is on top? Zinc. That means in the anode, zinc is the one which is reacting. Indicate the half reaction. Zinc goes to zinc 2 plus. Hurry. This is the answer. This is the answer for Roman number 3. Very easy. Now in this question, they have asked questions from all over the place. So you need to know everything to answer. Now they are asking about the cell U, cell W, cell U again. They are not asking everything. They are only asking one part. Then you need to exactly know from where to get it. So it's very important to have that short note and remember everything. Everything at one place. Instead of a long chapter, you have another short note. Hurry. Roman number 4. State the convention used to identify the anode and cathode in cell W. State the convention used to identify anode and cathode in cell W. What does that mean? Can someone answer? What does that mean? Answer Roman number 4. Explain to me what that means. What are the conventions? What are the conventions, lamai? Flow of electrons or terminal of, yeah, mainly conventions කියලා කියන්නේ for electrolysis in cell W, the conventions are which terminal is positive and which terminal is negative. That's the meaning of convention. Hari, state the convention used to identify, yeah, which terminal is negative and which terminal is positive. That's the convention. So you can either write anode is negative or positive, cathode is negative or positive, or else the easiest way is the positive end of the cell is connected to the positive rod. That's the actual way of writing the convention. Now you have just referred to your textbook. It says electrode connected to the positive terminal is positive. That's the convention. Electrode connected to the electrodes, those rods, ne? Electrode connected to the positive terminal, positive end of the cell is positive. Electrode connected to the negative end of the cell is negative. That's one way of writing. If you like it, that's easier to write. Or else you can determine which end is the negative. Now if someone asks me whether anode is negative or cathode is negative, I don't know. Hari, mama danne. Now for cell W, I'll just quickly draw a diagram and determine it. Within seconds I can do it. I draw the battery like this. This is positive, this is negative. Hari. Current flow is this way, then electron flow in the other way. Hari, electrons yanne homa. Hari. So electrons are getting accepted, so this is cathode. Electrons are going away, this is anode. Hari. Then this end is negative, therefore this is negative. This end is positive, therefore this is positive. Done. Then I know cathode is negative, anode is positive. No need to study. When I am walking on the road, if someone asks whether anode is positive or cathode is negative for a electrolytic cell, I don't know. I haven't studied it that way. I don't know. I need to draw a diagram and within 1 second I can say. That's enough. No need to study. Anyway, so that's the convention. You can either write for a W cell. W means what the W කියන්නේ? Electrolytic cell. Hari. Cathode is negative, anode is positive, or else the electrode connected to the positive end of the cell is positive, electrode connected to the negative end of the cell is negative. Both are accepted. Hari, both are fine. That's number 4. So we are answering the question number 6, part 4. That's question number 6 in the tune, part 4. That is 2020 A level. Hari. Dagan. Yeah, charges of the battery, exactly. So finally you can write anode is positive, cathode is negative. That's the convention. No need to study it. Now we know exactly how to derive it. Take a gun හැටි අපි දැන් දන්නවා. Roman number 5. Roman number 5. What change in color occurs in the electrolytic solution when cell W operates? For that we'll write the equations and see. See, the questions are all over the place. එකේක තැන් වලින් අහන ප්‍රශ්න. හරි. Cell W. What change in color occurs when electrolytic solution when cell W operates? We'll see what happens in cell W. Now we know actually. Cell W, you have carbon, you have a battery, we don't care. Then you have copper sulfate aqueous, that is copper 2 plus, sulfur 2 minus, H plus, OH minus. Hari. First we'll consider the reduction. The competitors are these two. What is the highest priority? Copper 2 plus. ඒක පොඩ්ඩක් මතක තියාගන්න. Remember that priority order. That's it. Hari, that is the reduction. For the oxidation, we don't care about sulfate. We only care about OH minus or Cl minus. We don't have Cl minus here. So OH minus go into O2 and then you can balance it like this, very easy. And we know that this reaction is wrong. Why? Sorry, this reaction is wrong because you can't write OH minus. You need to convert it to water by adding 2H plus. Then this is 2 water, O2, add 2H plus, then it's 4H plus 4E. See how easily you can derive this when you understand things. No need to study. Now I know most of you just study this equation. No need to study. Then this equation is wrong. Hari. You have this equation, you have this equation. Hari. Considering those two, we can answer. What change in color occurs in electrolytic solution when cell W operates? What happens? When cell W operates, lamai, you can see the copper 2 plus amount reduces. Copper 2 plus amount reduces. That's the only change which happens, which is related to color. Now, what's the color of copper 2 plus? What's the color of copper sulfate? Light blue. You have learned it. Copper 2 plus is light blue, isn't it? Then with time, copper 2 plus amount reduces. Then on. With time, the amount of copper 2 plus reduces. I mean, copper 2 plus is going to the other side. Now it's not copper 2 plus. It's copper then. Copper 2 plus is blue color. With time, the concentration or the amount of copper 2 plus reduces. Therefore, the intensity of blue color decreases. So, what change in color occurs? The intensity or the intensity of blue color decreases. That's the color change. It won't become completely colorless. With time, it can be. But normally, what happens is the intensity of the blue color starts to reduce. Then they are asking to explain the reason. You can say, considering the mono reaction, this is the reduction. This is the reduction. You can see it's a reduction. Hari. Considering the reduction, copper 2 plus reduces with time. Therefore, the blue color reduces. Hari lazy. Come. That's it. That's the fifth part. If you can answer a question like question 6, then you have a good understanding because it's not directed and guided. Everywhere. The questions are everywhere. It's a good question. So the fifth one, the color change, the blue color, the intensity of the blue color reduces. That's the color change. The reason, the amount of copper 2 plus reduces with time. What is it? Sorry. The final part of this, it says, which electrode is dissolved when above cells operate? Very easy. We don't need to even look at cell W. Why? Cell W is electrolytic. You know, in electrolytic, nothing happens to the rods. Always carbon, nothing will happen. Then the only attention should be paid to cell U. The only attention should be paid to cell U. Then what happens? In cell U, we know what decreases with time. Cell U, did we write the reactions? In cell U, the oxidation happens here. If you want, you can from the beginning start analyzing cell U if you want. Cell U, you have zinc, you have copper. Out of those, already we have realized that zinc is the one which oxidizes. Again, this zinc cell will start to spend, start to react, start to dissolve in water like this. And then with time, the zinc rod will dissolve when the cell operates. That's very easy. Cell W no need to be considered because we know all the rods are inert always, carbon. So that's the sixth question. Okay. Shall we try the yeah, shall we try the second question on the tube? Then go. Come to the second question. Now the first question and third question is related to the corrosion part. You can try the fourth and fifth. I'll do the second about the down cell. There can be some points which are directly connected, some theory points related to down cell. We'll see whether that's the case. But most of the parts can be answered at the moment. Come to the second question. Any issues up to now? Hari. We have around 30 minutes maximum. We'll try to answer the second question. Podi try එකක් දෙන්න ළමයි. There will be a small noise for some of you. Just ignore it for the moment. කට්ටිය බලමු try එකක් දෙමුද? Shall we try the second question? දෙවෙනි ප්‍රශ්නේ පොඩි try එකක් දෙමු. I'll give you 5 minutes to answer the question. It's very easy. You can answer. Now, some questions I haven't addressed, like why a graphite anode is more suitable than a steel anode. Those things you can think. I'll help you, but try to answer the question. Always remember, in a revised session, we can't cover everything. So, it's your responsibility to do more and more questions and see which parts we have missed. Alright? Give you time until I think it's 10:43. I'll give you time until 10:48. කරන්න බලන්න පොඩ්ඩක් try කරමු. by H plus or H minus, that's why. Therefore, we add respective ions and convert those OH minuses and H plus to water when we are finally writing the equations. That part is explained. What passadikin බලන්න පුළුවන් on the live. හරි. You have 2 more minutes. You are there. You are and tell me if you have finished. Drop a message so that I would know. And just reminding you, online lamai me online තමයි හැමෝම. If your questions did not get answered, I can see more than 100 messages are there on the Zoom chat to answer. Send a text to that number I gave you. Hurry. In all the graphics, if you just pay attention to, now some of the students had difficulties on finding the number. Just go to the channel, there are graphics, there are so many things sent. In all of those, we have that number. So send a text, and you will get a reply. Done. Already nice. I will give you 1 more minute, then I'll discuss this question. Hari ආගන්න. Pay attention. ඉවරද කට්ටිය? Still doing? කමන්නේ. පොඩ්ඩක් අහන් ඉමු. හරි, I'll discuss this question and I need to get an opinion on how to cover the other part, the corrosion part. So we can have, I think we have things to cover if we want. We have the electroplating if you want me to teach that part. So that part hasn't been taught, electroplating, which is a specific part of electrolytic cells. And then we have the corrosion of metals. We'll discuss that later. Anyway, in like 10 minutes, 15 minutes, we are done. Sodium metal is extracted in down cell by electrolysis of fused. Fused means molten, means the liquid form, sodium chloride. Again, NaCl liquid. So what we do is not dissolving NaCl in water. We heat NaCl until it's liquid. So it doesn't contain water. It's NaCl liquid. The graphite anode, obviously the anodes and cathodes are graphite for electrolytic cells for us. And annular steel cathode. In theory level, even though for us the anodes and cathodes are graphite, sometimes in industries they might change those anodes and cathodes. They can make again the cathode is steel. Anyway, now I don't want to draw the entire down cell, but we'll just draw the down cell in a simplified diagram. Now, of course, this is not the down cell, but we can draw it in a simpler version. Then you have sodium chloride liquid, Na plus liquid and Cl minus liquid. Still it will break down into ions, but it's now liquid form. Hari. Then one is cathode, one is carbon, graphite means carbon, the other one is steel. Hari. And then of course you have a battery and we don't know which end is positive, we don't know which end is negative, it doesn't matter. Hari. We actually know, we can actually find which end is negative or which end is positive. It says the cathode is anode is graphite. Then this is anode, this is cathode. Hari. Anode කියන්නේ මොකද්ද? And what is anode? Anode is the direction electrons go away. So electrons go away in this direction. See, when you know logics, it's very easy to derive anything. ඕන එකක් හදා ගන්න පුළුවන්. Hari. Anodes, electrons going away, electrons coming back. Then this is the end. Yeah. So this is the positive. If you want, you can even draw the cell on top of it, because current is flowing in this direction, electrons are going in this direction now. Not required for the question, but if we need, we can even. Why sodium chloride should be fused in this task? Because anyway, we can't use it in an electrochemical cell, or sorry, electrolytic cell as the solid form. Solid NaCl won't act as an electrolyte. So here now you are adding liquid sodium chloride. You can't have solid sodium chloride as an electrolyte. That's why we have to fuse it. That's why we have to liquefy it. Hari? Right. So point 1 you can write, sodium chloride solid is not a electrolyte. So you need to fuse it and get the version. Hari? Right. You can't hear me? Anit lamai? YouTube ලා මට පොඩ්ඩක් කියන්න whether you can hear me or not. ඇහැ නේද? ඇහෙනව නේද? ඇහැ නේද? ඇහෙනව YouTube ඇහෙනව? හරි. ඇහෙනව නෙච්චර. හරි. Zoom ළමයට ඇහෙනව. Zoom ළමයට ඇහෙනව. හරි. Right. Then Roman number 2. Indicating the relevant physical states, write the ion electron half reaction relevant to discharge of sodium metal on the cathode. Indicating relevant physical state, write the ion electron okay. What happens? Now ion electron half reaction relevant to discharge of sodium metal. Sodium metal, one reaction might be involving sodium, they are asking to write that. That's right. Now we know what can sodium do? Only the reduction. Now what? Just think of the reducing theory. For reducing there were 3 competitors, copper 2 plus, H plus, sodium plus. Sodium plus might be the last place, but here we don't have any of these. Then sodium plus. It's very easy. Sodium plus liquids goes to sodium, and then here 1 electron. Now if you are finding it difficult to study whether it's liquid or solid, logically done. Why is sodium plus liquid here? Because the heat is very high. The temperature is very high. That's why it's liquid. Then when sodium is also formed, it gets affected by the temperature. So again it's liquid. That's why it's liquid. Done. That's Roman number 2. Roman number 3. Right. Okay. Why a graphite anode is more suitable for this than steel anode? Anode. What happens if this is steel? Can someone answer what happens if this is steel? Why is it? What is the issue? What's the issue with steel? Now what is steel? Do you know? How do we make steel? Lamai, steel is a combination of iron and carbon. It's an alloy. Alloy is a combination of metals. It's a combination of Fe and carbon. Now carbon is okay, it's inert, but Fe isn't inert. Fe can oxidize. Now as a policy in all of our cells, the rods did not oxidize. That's why we can't have this as steel. Then you might ask, is it okay having this as steel? Make a steel. Carbon is anyways okay. Fe can't reduce. This is the cathode. So cathodes won't anyways oxidize. So no need to fear about it. So So this can be steel because having a metal which can oxidize is fine because the cathode won't oxidize. It oxidize when the that's why. But here for the anode you need to always have carbon or graphite. If it is steel, it will involve Fe which can oxidize, which will completely disrupt the process. May process case. That's the issue. Right? So the answer for Roman number 3, graphite is more suitable because steel contains iron which can oxidize. We don't need that. That's why Roman number 3 is the anode is graphite. දාගන්න එකත් okay. Finally, Roman number 4, state one application of sodium. Now, that thing it's theory in your resource book. There are several applications given, such as vapor lamps with yellow color. Have you seen those? Arame. And then in experiments to prepare nuclear energy. There are like many more examples, but I don't want to give those because that's just theory. You can remember those if you need. Hurry. And if you have seen what a yellow color lamp is like, in physics labs we call it yellow light. It's a different kind of a light which is caused due to sodium. Sodium has a yellow color. In A levels we do a thing called flame test. Even in the flame test, sodium shows that yellow color. So yellow is connected with sodium. That's why for yellow color lamps we can use sodium vapor. Anyway, that's just theory. I'm not going to attend that question. You can understand. Sorry, mama theory part tika karanne. Anyways, if you have to study, then what can I do? Fifth one, scientist Humphrey Davy. Now that part is given to check whether you can think, whether you know, or whether you have just studied. Sodium metal by electrolyzing fused sodium hydroxide. Now that might not be given as an example. In your syllabus, this kind of a cell hasn't been given. They have given few electrolytic cells. Such as aqueous copper sulfate. This is molten sodium chloride. This is the one we did now. Then there's aqueous sodium chloride as well, and then there's acidulated water electrolysis. Now they have given one asking you to think. Again, no need to be afraid. Why? Because we know a method which is applicable for every question. So no need to be afraid about it. No need to be afraid. We know all the methods. We know a method which goes with every cell. No need to even use the hint. If you want, you can use the hint. You can try to use the one, but no need. Now here they are saying you have a cell. Anyways, we know in electrolytic cells for O levels all the rods are neglected. Both are carbon. And then they are asking to fuse sodium hydroxide. Fused means molten. That means sodium plus liquid and OH minus liquid. Fuse is another term for molten. You can see in the first question also they are saying fused in brackets molten. This is OH minus liquid. That's it. So since it is fused, since it is molten, it won't have one other. It won't have liquid. Water. It won't have water. H plus OH minus. Now what they are saying is Humphrey Davy discovered sodium. Now what they are asking is write the anodic reaction. On the anode here. Write the anodic reaction. Anything very easy. For the anode, we have only two options, OH minus and Cl minus. Do we have Cl minus here, no. So it's only OH minus. මෙච්චරයි. OH minus goes to O2 plus 2H plus sorry, මෙතන දෙකක් දාගත්තා, then 2H plus then 4 electrons. That's it. Done. So maybe Humphrey Davy oxidized OH minus and then sodium plus might be reduced. That might be the way he found sodium. That's not relevant to us. They are just asking us the anodic reaction. For anodes in this case it's only OH minus and Cl minus. We don't have Cl minus, so it's only OH minus. Now if you are thinking to yourself, මෙතන පොඩි trick එකක් තියෙනවා. This is a small trick. If someone does this, is it correct now? මතකද I said that having OH minus or H plus is wrong. Therefore we need to add 2H plus and make this 2 water. So we need to add 2H plus to this side as well and make this O2 plus 4H plus 4E. Is this correct now? මේකද හරි දැන්? Can we do it here or should we do it here? Yes or no? If not, why? Now I am of course asking because that shouldn't be done here. It's wrong here. If we do this and get this blue color equation, that's wrong here. Why? ටක් ගාලා කියන්නේ. So you need to understand things. නිකන් පාඩම් කරලා ලියලා හරියන්නේ නැහැ. Here it's different. Why is that wrong? කියන්න බලන්න. ඇයි ඒක වැරදි? Online lamai, any answers now? Yeah, exactly. There is no water. Exactly. So here did we get OH minus by water? No. Automatically, originally we had OH minus from sodium hydroxide. It's different. Arave OH minus and H plus was given by water. Then you need to correct it and mention that it's water, not OH minus or H plus. Hurry. You think here sodium hydroxide has a lot of OH minus. So it's correct writing sodium hydroxide as OH minus. Then we no need to correct it. So remember, if we write OH minus and H plus instead of water only, we need to make the correction. Otherwise, no need to make the correction. Hurry. Yeah, it doesn't contain water. Exactly. And anyways, you can write this because it's fused. Fused ne, vadura naha kohomad. Hurry, that's not the perfect answer. That's not the perfect answer. Even if this was sodium hydroxide aqueous, hitan instead of this being fused, hurry, that's not the correct answer. It's not because it's fused. Hurry, mokada this OH minus was given by sodium hydroxide. So that sodium hydroxide gives a lot of OH minus. It's a base. Eka bashmayak, eka base ekak. It will give a lot of OH minus. So it's correct writing it like this. Hurry. Now some of you are saying you can't do this because it's fused. That's not exactly correct. Imagine it was sodium hydroxide aqueous, then you will have Na plus aqueous, OH minus aqueous. From water also you will get H plus and OH minus. Neda? Again in the anode what happens is this. Again in the anode this happens. Again converting it to this is wrong. Why? Why are we actually converting water? Why did we actually convert this to water? Because we know OH minus isn't the correct representation for water. So wherever we have water, wherever we break water to H plus and OH minus, we need to correct ourselves. I think metana, even if we ignore water, still you have a lot of OH minus. So no need to make this correction. So remember, in case you get OH minus or H plus from water, you need to correct it. But if you are getting OH minus or H plus from an acid or a base, so from a base you will get a lot of OH minus, from an acid you will get a lot of H plus. Then no need to do the correction. That's it. So you can add that to your note if you want. I am repeating, from an acid or a base, if you get H plus or OH minus respectively, no need to do the correction. If that H plus or OH minus from water is given, then that needs to be corrected because water won't give that much H plus or OH minus. You need to correct it as water again. Hari? That's the difference. Hari, that's the difference. Right, so that's question number 2. Okay, so I want you to try question number 4, which has some parts which is not directly relevant to the electrolytic part. For question number 4, I think you can do Roman number 4 and 5. Ne? No. Roman number 5. Do question number 4, Roman number 5. That's the only part from electrochemistry there. Ilangata question number 1 gathot ehema that contains corrosion, I think. We'll see what we haven't done, what we could have done but could not do due to time management. Question number 3 is corrosion anyway. ගත්ත අවුලක් නැහැ. Hari. And then question number 3 hari, 4 hari, 5 you can do, 5 try, 5th one try, 6th one I did. So we have only missed a very few ne. 5th එකෙත් I think 5th එකේ few parts can be done ne. Mainly Roman number 5 and 6 I think. Mainly Roman number 5 and 6 is related to electrochemistry, not the entire question. So we haven't missed lot. පොඩ්ඩක් තමයි කරගන්න බැරි වුණේ. හරි. How was the session? We'll take another 5-6 minutes and finish things. What is the answer for the Roman number 5? 5 from question number 2, I think I told you. That's theory. Uses of sodium, you can find like yellow color lamps. There were like few more uses. Think you can do that, up to you. Not going to. shape එක ඇහෙනවන්නේ හරි දැනනවන්න නෑ නැහැ. ඇහෙන්නේ නැහැ කියලා නම් කියනවා කට්ටිය. ටක් ගාලා. Now you can hear me. Yeah, how was the session? කියමු බලන්න. පොඩි idea එකක් දෙන්න. Did you understand shape the okay the අවුලක් නැහැ නේ. හරි right. I assume everything went smoothly apart from few technical issues I think which we have to expect එක කොහොමත් වෙනවා YouTube live එකක් දුන්නම පොඩ්ඩක් එහෙම වෙනවා. Yeah, I know. Right. Yeah, කොහමද? වැඩේ සෙට්ද තේරෙනවද? ඕකේද අවුලක් නැහැ නේ. shape නේ වැඩේ වුණානේ. Right. Okay. So what I want you to do is I want a brief idea now. We'll spend like 3-4 minutes to get this clear. හරිද? Now anyways I have planning a past paper discussion on 20th. If we need to change the date, we'll do that. That's something else. But before that, from today's session, apart from the electroplating part, everything as a summary has been covered for electrochemical and electrolytic. So what I want you to do is this. Depending on your level, you can decide if you want to do more or less. So this is enough for you. If you are weak, if you still have issues, one, you can go through the recording again, go through the live again. I'll keep it for like 1 or 2 days maximum. 2, try the remaining questions. Now in this tute I have included all the past papers for the last 5 years. So you can try the remaining questions except for 1 and 3. And then if you have any questions, send a text to the number. Solve karaganna. I'll attend to those and I'll answer your questions. There might be some MCQs as well which is not on the tute. ඒවත් පුළුවන් නම් කරන්න. පුළුවන් තරම් ප්‍රශ්න කරන්න. Especially if you have only knowledge for electrochemical cells and electrolytic cells from this session. මේකෙන් නම් ගොඩක් දේවල් ඉගෙන ගත්තේ. Since this is a revision, not a complete theory session, I tried my best to finish most of it. It's better to do the questions. ප්‍රශ්න කරද්දිත් පොඩ්ඩක් set වෙනවා. ඒක එහෙම තමයි ළමයි. හරි? It's impossible to cover everything from a one session. Obviously තේරෙනවනේ. So it's better for you if you can try questions and ask the doubts. Then we still haven't done the corrosion part, and if you want I can teach you that electroplating part as well. So do you want a separate seminar for that? Yes or no? Now I'll send a poll to the group as well if I feel, but can you give me a response on the YouTube chat to check whether that's even worth considering? So do no Roman number 4 Roman number 5 ඒක නිකන් මට send a text, I'll help you. කියන්න බලන්න ළමයි. Zoom එකේ ළමයි just react something මොකක් කරේ thumbs up එකක් කරේ මොකක් කරේ react කරන්න if you want me to do a session for that, the electroplating and corrosion part. YouTube එකේ ළමයි you want one? ඕනේ වගේද? Okay. ඕනේ වගේ නේ. අම්මෝ චරෝනේ right. හරි. Okay, if you want if at least like 10-15 students want me, I will right, then we'll have a session for the electroplating and the corrosion part. Again, we need to fix a date for that, so it's your responsibility to respond on the WhatsApp channel, because we can't spend a lot of time deciding, because I have to plan others නේ. ඒ කියන්නේ මේ අපේ normal schedule එකේ free වෙලාවල් හොයාගෙන තමයි මේව දාන්නේ, because this is not a fixed thing for me නේ. O level seminars is not a thing for me නේ. හරි. ඒ කියන්නේ classes නැති වෙලාවල් බලලා students are doing A levels, we have a lot of work on that side, so I can do it, it's possible, but respond on the channel එකේ respond කරන්න on what date when we can have it. Hari, I'll give you some options and vote on it, and then we'll decide when to have the session. Hari, so we'll have a separate session to cover electroplating and corrosion as well, and meantime you can finish the other past paper questions, and if you have any question related to what we have done already, කරපු ටිකට අදාළව send a text to this number, I'll reply as soon as possible. Hari, maybe I think I'll be able to reply tomorrow. විශේෂයෙන් මේ Zoom chat එකේ there's a lot of questions, I think. If you have those, reply. Yes. If those are solved already, fine. If not, reply. Hari, that's one. And then anyways, we'll have a past paper discussion session. We'll see when that will be held. Definitely we'll have to change the dates නේ. For the moment, එක 20 ද කොහෙදන තියන්ති මේක මොකක් කරේ කරමු. Hari, එහෙනම් I think that's it for today. You know the help you can do me, the favor you can do me. I always expect only one favor from you, is to share the message among your friends. Because more students join, I am more happy. I think it's right. Share the message among your friends, and after the live is ended, if you have a comment or a feedback about the session, don't send it now to the live chat. Even the Zoom students can type it on the video after the live is ended, and then we'll have a good idea on how to improve or whether we have done enough or not. Right, then that's it for today. අදට ඔච්චර තමයි. මහන්සියදි කට්ටියට thank you. I think තාමත් ගොඩක් අය ඉන්නවා වැඩේ අහගෙන, and we had some technical issues. Even ඒව තියෙද්දිත් වැඩේට සෙට් වෙලා අපිත් එක්ක හිටියට thank you. Then we'll meet on the next session. හරි? Yeah. අදට ඇති. මොන හරි issues තියෙනවා නම් contact us. Yeah, we'll meet soon නේ. Next session will be happening in few days. I think no need to waste your time. ඇති කතා කරා. We'll meet soon. Yeah. Good night. Bye bye. Right. මේ අනිත් ඒවාත් අපි කරමු. මේ අනිත් මොන හරි suggestions තියෙනවා නම් you can send it to the මේ number. Hari, any suggestions on any other sessions, send it to the number. We'll end the live. Give your comments on the video after that. Hari? Okay. Okay.